In the lesson 4.7 example, how many ways can you arrange the batting order? We're going to find the number of permutations for a group. A youth baseball team has 15 players. We want to select and arrange 9 of those players to make up the team's batting order. The other 6 are going to be on the bench this game. So if we wanted to, I wouldn't advise this, but if you wanted to, you could say, well, we have 15 choices for the first batter. And if we select this first batter here, we have 14 choices for the second batter. Now those 14 choices for the second batter would apply had I chosen this person up here, or this person down here as my first batter, or this person here as my first batter. What we notice is this is becoming very unwieldy as a tree diagram, but this helps us to at least illustrate that out of these 15 choices, each of those 15 choices has 14 choices for the second batter. So we have 15 times 14, which is 210 choices for the first and second batter in order. Now, we're not going to continue this tree diagram because we have to arrange 9 players. Can you imagine a tree diagram that had 9 such decisions on it? It would be really, really big. So we're not going to do it that way, but this tree diagram did give us some sense of what we're going to be doing numerically. And that is to say, we have 15 choices for the first batter, 14 choices for the second batter, and so on. What do we mean, and so on? Well, it's the number of choices for batter number 1 times the number of choices for batter number 2 times the number of choices for batter number 3, etc., until we have 9 batters. That's going to be 15 choices for batter 1, 14 for batter 2, 13 for batter 3, etc., until we have 9 batters. This is first, second, third, fourth, fifth, sixth, seventh, eighth, and ninth batters. That leaves us with over 1 billion different batting orders, 1.8 billion different batting orders. Just a note, this calculation can be rewritten as 15p9. This is a notation that you'll see fairly often in your textbook. What this means is that there were 15 batters, and we want the number of permutations, that is, arrangements, of 9 of those 15 batters. If you'd like to try an exercise like this in your textbook, you can try exercise 9 in this section.